Okay, guys, I think we can start today's session. Okay, so first, I just want to start with the last chapter that we have discussed uh, when we just post the course. Okay, so let me take the GitHub. Okay, so just want to show you the topics that we have discussed before to get a continuity. Okay, so if you check the GitHub, you can see the topics that we have discussed at the end. In the last class, it was about navigation. So if you remember, I was actually explaining like how to create a mobile robot and like interface into navigation stack. Okay, so we have seen some examples, but we have something to discuss more about about this chapter. Somewhat more I need to discuss, but these were the last topic that we have discussed. Okay, and there was two session, and I talked about ROS navigation stack and how to fine tune. I mean, an abstract concept of like fine tuning, and how to map, how to do the localization in a very brief manner. Okay, so we will get back to this chapter again. Okay, but I think the things that I mentioned in these two videos will be enough to get start with the projects. Okay, mainly like you can able to create some projects. Okay, you can create some projects in simulation and start interfacing to the navigation stack. Okay, so yeah, so this was the last topic, but today we are actually trying to focus more on a new chapter, which is the ROS perception. Okay, ROS perception. So yeah, so I think we already discussed about OpenCV before in our introductory uh, chapters. If you remember, like we discussed about OpenCV PCL. So this was a chapter. So we discussed about very basics of OpenCV. I'm not sure you remember it. OpenCV stands for Open Source Computer Vision. So the lectures are already there in the GitHub if you search, but I will give an explanation again, no problem. Okay, so we have actually discussed about OpenCV PCL. So in this chapter, in the new chapter, what we are planning is how to interface this OpenCV PCL library to ROS. Okay, so first I would like to give you an idea like why we need to discuss this chapter. Okay, so let's see. First, I just want to show you some robots. Okay, maybe a robot uh, in agriculture. Yeah, I think this is one robot that I'm looking for. Yes. Just a second. Okay. Yeah. Even I think this is kind of illustration, but this is the main point that we are going to discuss. Okay. So ROS perception or robotic perception, why it is important. So the perception means, I mean, seeing. We are perceiving through our eyes, right? So similarly, robots can perceive through cameras, different kinds of cameras, or like using lidars and all. So this robot is actually an agriculture robot. Okay, this robot, you can see a robotic arm. This is a robotic arm. Okay, and there should be a mobile base means a wheeled robot just under this robot. So what happening is that the wheel robot like this the wheel robot will be moving in this line and it will harvest. Okay, that is the fundamental idea. Instead of human beings, these wheel robot can move around and uh, do the harvesting. Okay, this is actually using in many industries. Actually, specifically saying in Netherlands, they have a lot of horticulture, they have indoor farming and all. So in order to harvest, some companies are using robots. Okay, and a lot of research is happening on this kind of application like harvesting. So how can we do this kind of application? How can we implement this kind of application using robots? So like this, uh, like we pick a tomato, the robot has to pick the tomato from the tree. I mean from the plant. So it it looks simple, but it's not easy. Okay, Archita, can you mute your mic? Okay, thank you. So the idea is for this robotic arm, you can see a camera here. Okay, so the camera is acting as the eye of the robot. Okay, so the camera can able to detect this crop. Here it is tomato, and it can find the position of the tomato, and then it is actually calculating the distance from tomato to the robotic arm or the gripper. So this is the gripper, like our hand is having 5 fingers, right? Here you can see it is having only two jaw gripper. Okay, so from the vision it is identifying the crop, and from after identifying this camera, this camera is connected to a computer. Basically everything is connected to a computer. So then after detecting the crop and computing the distance, the computer will send a signal to reach into this near to this crop. Okay, and initiate some grasping sequence to take the crop from this branch. Okay, if we say these steps, it is very easy to say. I mean, it's very easy, like detect from the camera and take it from the branch, but in reality it's too difficult. It's very difficult. I can say why. Because the orientation of the crop, the placement of the crop is very random. Like the tomato can be in can be in any position. Okay, in any orientation. Maybe some tomato can merge. If we apply some algorithm, it will look like one. So there are a lot of challenges in this kind of application. Okay, so how can we approach to this kind of problem? Okay, not only for agricultural robotics, but for all robot which is having some cameras. Okay, so that's how that's why this chapter is relevant. The perception means how we can process the image data coming from this camera, and how can we uh, process this image and make some sense out of it. Make some sense in the sense, like from an image, like just detect a crop, or like detect tomato or something like that from the image. So the robot has to understand the scene, right? Like what the camera see is just the visuals. From the visuals we have to do some processing to identify the crop and all. Okay, so how to do the processing? The camera is giving the image. How to do the processing? The processing can be done using these kind of libraries. The first library is called OpenCV, Open Source Computer Vision, which is actually using for 2D image processing, but now they have added a lot of functionality to do 3D image processing as well. So 2D image processing basically means the camera, we all have the webcam, right? So the image from the normal webcam we can call the 2D image, because it's actually in a plane, right? In a plane. So OpenCV can be used to process the images from the webcam or from the video stream, or from an image, single image. Okay, whereas the point cloud library, okay, the point cloud library, uh, maybe I can show you the OpenCV library website. I think most of you have seen it. This is OpenCV website, and you can see the project or the library from the GitHub. Okay, maybe I can just share the website and all, so you can have a look. I mean, you are familiar with it, but I'm just mentioning. Whereas the point cloud library is again very useful, very useful for 3D pick and place or 3D grasping. Okay, it's very important because when you approach these tomato, okay, the tomato is a 3D object, right? It's a 3D object. So if we identify the tomato using OpenCV, we don't know the three-dimensional aspect of the object. We only know the position of the tomato with respect to the image. But if we have the point cloud data, okay, point cloud, I think you may know, for beginners I can say point cloud is the 3D data of the environment. Okay, so there are cameras called depth cameras which can come up with, which can output this kind of 3D information of the environment. So once we get the 3D information, again you can do the object detection, 3D object detection in this data. Okay, so in this chapter we are seeing two kind of library. One is for 2D image processing, and second, that is a point cloud library, is for doing 3D perception or 3D image processing. It's not an image, but it's for 3D application. So both are useful for robotic application. So first I will give you an introduction to OpenCV, like very abstract idea, and point cloud. Then we will be seeing how to interface OpenCV PCL to ROS. Okay, I have some examples as well, so I can show you. Okay, and I can also mention why we need to interface OpenCV PCL to ROS. Okay, there should be some objective, right? Why we are doing this interfacing. Okay, so let's start with OpenCV first. So I have shared the website link, OpenCV. It's a very old library in computer vision. So like I think it started in 2000 or something. If you check the OpenCV Wikipedia, you will get the development. It started, yeah, initial release date was 2000. So currently it is managing by Intel. It's an open source library for doing image processing, specifically computer vision application. Okay, so from 2000 there are a lot of companies actually transferred. I mean, from Intel it was acquired by some other companies, and then at last now it is again developing and maintaining by Intel. Okay, so it's a free software and open source, and it is written in C++ and C. And this library, I think you all know about what is a library. Library is the collection of functions, okay, for doing computer vision application. So if you want to do an object detection or face detection, you don't need to implement it from scratch. The function is already available in OpenCV, so simply call that function from your program. So that is the use of a library. So OpenCV library is having a big collection of computer vision application for doing object detection, filtering, then face detection, people detection. I mean, the list actually, it's very big. Okay, so these kind of applications are very common in robot Like if we want to do some color detection in robot, we can simply use the OpenCV. If we want to do some people detection, we can use OpenCV. Okay, and we can create applications using C++, C, Python, Java. I think we can create even application using Android. Okay, so OpenCV is compatible with almost all the programming languages, even C Sharp, MATLAB, everything is compatible. And also regarding the operating system, OpenCV can be compiled and built in Windows, Linux, and Mac. Okay, so even in Android you can able to work with OpenCV. So it's cross-platform. You can create application using C++, Python, okay, C, Java, okay, and this is the GitHub repository of OpenCV. It is having the I don't know, like it is having the instructions, but instructions, I think the compilation and all, I think I have mentioned in the 23rd lecture that we have already, I think we already covered the installation building of OpenCV. It's very simple. We can use cmake command to build it. Okay, if I have the OpenCV with me, maybe I can quickly show you the compilation step. Yes, I think I have. So what you have to do is, in order to install OpenCV on your computer, there are two methods. One is installing from binaries. Binaries means like it's already it's a pre-compiled files, so you don't need to build the source code and install. The second option is building from source. Building from source means the OpenCV is actually a project. Okay, so, it's a software project. So installing from binaries means it will be already pre-compiled and you can directly install to your system. So it will not take much time. But building from source means it's a software project, right? So you have to compile each and every source code written in C and C++ using some compilation building tools. Okay, so in order to install OpenCV on Linux, because we are mainly dealing with Ubuntu, so in order to install in Linux, I think you don't need to do anything other than installing ROS. So using Synaptic Package Manager, which is the package manager that we are using in Ubuntu, you can simply install ROS Desktop Full, ROS Neutic Desktop Full. So if you install it, I hope it will be installing all the OpenCV library, because this desktop full now, it will be installing all the packages, and one of the dependency of this desktop full is OpenCV. Okay, so if you check the perception package, okay, so ROS is having a meta package, means like this is one meta package which is handling all the packages for doing perception. Okay, so if you install the perception package, that means you have installed OpenCV, you have installed PCL, you have installed ROS wrapper or ROS interface for PCL and OpenCV. Okay, so it's just a matter of like install a desktop full and then check whether the perception package is installed. Okay, so if it is installed, then we are sure that you have set up the development environment with OpenCV. Okay, so you can see it's already installed and it's ready for updation as well. I'm not doing the updation now, but yeah. Okay, the package name is ROS noetic perception. Okay, so this is a very easiest way to install OpenCV on Linux. Okay, I'm not talking about Windows right now, but it is very easy. There is an installer or extract zip file, so that you can simply unzip that file and you will get the binaries, and you have to set the environmental variable, and also it will work without any issues. Okay, so in order to compile it from source code, here is the source code of OpenCV. I already cloned from this GitHub, so simply download it, or you can simply clone it. Okay, I hope you are familiar with Git cloning, so you can simply clone it. It's a public repository, so you will get a folder like OpenCV. Inside there is this much of files. Okay, and in order to build it, I think you're familiar with the CMake, how to build it. Like, you can simply create a build folder like build. Okay, and then you can use the CMake command to build. So one of the easiest method to build OpenCV is using CMake GUI. Okay, CMake GUI. So if you have the Synaptic Package Manager, just search for the CMake GUI. It's a GUI tool of CMake, very easy to work with. So make sure you have installed this tool. Okay, this tool. So this tool, this is this tool. Okay, so it's very easy to work with. First, we have to browse the source code. Okay, so here the OpenCV is the source code folder, and now we have to point out where to build the binary files. Okay, after compilation of the source code, we have to build the binaries, right? So the binaries will be going to the build folder. Okay, and then simply configure it. So the configuration step is actually like, while building the OpenCV, there are tons of configuration that we can do. Okay, so like you can enable, disable lot of flags. For example, OpenCV contrib is one third-party extra modules available in the in OpenCV. So if you want contrib, you can add it. Like that, there are many configuration. So if you want to build the OpenCV like Python module, you can enable it. So like that, I mean, by building from source code, it's very flexible. Okay, you can enable whatever you are interested in. Okay, but make sure if you are planning to build and install OpenCV, the steps are like configure and generate. Okay, generate means it will be creating the make files. Okay, once we get the make file, currently it is showing some error, but once we get the make file, it's very easy. Like, just do the command make, then it will be making the OpenCV for you. Like if you do the OpenCV build and make, okay, so it will be like making everything. And then after do the making, there is an error now, but do the sudo make install. So this will be installing OpenCV into your system. Okay, so but just ensure that like there will not be any conflict with the installed OpenCV by binaries or installed OpenCV from source code. For example, if you just search for OpenCV-dev, which is the development package, you will get the OpenCV version from here. Okay, the current OpenCV version from the binaries is 4.2.0. Okay, one of the disadvantage of installing OpenCV from binary is that most of the time we will not get the latest version of OpenCV. Okay, so here you can see the latest version of OpenCV is 4.6. Okay, but from binaries we are only getting 4.2. Okay, so if you want to update something in 4.2, you have to, like currently we have installed 4.2 in our system, right? So if you want to install some extra things in the currently installed OpenCV, you may have to clone the 4.20 version. Okay, and also if you want to try the new OpenCV, what you can do is you can build the OpenCV. Okay, no need to install it. Okay, so the difference is that if you do the make command, okay, if you do the make command, OpenCV will build locally. Locally means inside the build folder. Okay, but once you do sudo make install, the local build library will be going to the system path. Okay, that is the main problem. Like when you do the sudo make install, it will go to system path, and in system path there is another version. Okay, so there is a conflict of 4.2 and 4.6. Okay, so you have to be careful. So if you are not doing the sudo make install, you are actually safe. You are not touching the system OpenCV, but you can use the library build in the build folder. Okay, then when you compile your own OpenCV program, you can set the include path and library path into this build folder. Okay, so your program will be using 4.6 instead of 4.2. Okay, so there are a lot of things like that, but for our purpose, the default installation will work. Okay, yes, so this is applicable for OpenCV and PCL. If you search for PCL, you can also find libpcl dev. Okay, so the PCL version is 1.10. Okay, so everything is actually set. Okay, so I hope you got an idea about OpenCV library, and now the PCL library is another. I think I have shown this as well in the introductory session. So PCL is mainly for the 3D, and these are the modules, separate individual modules available in the point cloud library. Okay, it's installed in our system, and there is a good tutorial as well. Okay, good tutorial available. Yeah, so you can work on PCL with C++ basically, and it's very easy to work with PCL library, but working with PCL data is somewhat complicated because it's a 3D data, right? So imagine how to do the object detection and all. It's not as easy as the 2D object detection. Okay, but we can able to do that actually. So PCL help us to interface the 3D depth sensors. So I hope you know, like Intel RealSense. So these kind of depth sensors into the PCL library. I mean, we can just work with these kind of devices. I think for Intel RealSense, the PCL is not compatible, I guess, but some other devices we can simply open it from the PCL itself. Okay, but the role of PCL comes after getting the data from the depth sensors. Okay, so these depth sensors can output the point cloud data. Okay, the point cloud data like without color or with color, you can create from the depth sensors, and also not only depth sensors or from the velodyne like LiDAR. Okay, these kind of sensors can also output the point cloud. But one problem, not a problem, but one thing is that these kind of LiDAR will not have the RGB content. It's only have the intensity. So if you can check this, it doesn't have the RGB. It's only have the intensity information. So PCL is a group of points, right? So that point doesn't have the RGB information like the depth sensors. Depth sensors, the advantage of depth sensor is that the depth sensors comes with a camera. Okay, so for example, the Kinect, okay, Kinect depth sensor. So you can see, because of the camera, it can fuse the 2D image and the 3D point cloud. So we will get the 3D point cloud with the RGB content. Okay, that is not possible with the Velodyne. Okay, but we have to separately put a camera along with Velodyne and do some sensor fusion for adding the image data or the RGB data into the point cloud. That is also possible. Okay, so this kind of data is processing by the point cloud library. Okay, there are a lot of opportunities for people working in the perception side, because perception nowadays are progressing on the deep learning, deep learning stuff. Okay, like basically the PCL, OpenCV are using for filtering and some kind of modification of the data, but after that everything is by deep learning, by trained models, neural networks. Okay, so the data that is coming from the depth sensors may be pre-processed by point cloud library, and then it may be feeding directly into some network. So maybe some kind of sampling can be done using point cloud library, but other stuff, the object detection, everything is handling through training. Okay, so this kind of classic object detection means like without any training. Okay, so if you are doing some detection with some algorithms, without any training, maybe we can call it as a classic methods. Okay, we are not doing any classic methods means those are old as well, because nowadays everything is based on the training. I hope you heard about the CVPR conference, which is the biggest conference for computer vision. So nowadays it's very trending, and there are a lot of participation for the CVPR, because most of the companies working on robotics, like mainly self-driving cars, are developing a great vision stack. Okay, mainly the innovations are happening on the vision side. Like for the self-driving car, the vision actually matters a lot, right? So the CVPR conference, you can check the papers. Some of the papers are, I think, open source, so you can check a lot of works happening in the vision domain, mainly in the deep learning part. Yeah. Yes. So that is PCL, and PCL can be installed using source code. So just check PCL GitHub. You will get the library. Yes, this is the PCL library. Okay. Yes, it is compatible with all the operating system. Yeah, and the compilation instructions are also given. It's using the CMake. Okay. Yeah, so that's about the PCL OpenCV. Now we can talk about the ROS perception. So if you just search about ROS perception, you will get the packages of perceptions. Just a second. Yeah. Yes. So these are the packages available for doing perception with ROS. So basically, just a sec. Perception. Yeah, vision OpenCV. Perception PCL. Yeah. So the perception stack in ROS. So what are they doing actually? So what is the role of perception, or like why we are using ROS in the for doing perception? Can anyone say what is the role of ROS for doing image processing? Like we have OpenCV and PCL, right? We have OpenCV and PCL. So why we are using ROS with OpenCV and PCL? Like why we are using, but we can simply use PCL or OpenCV and create programs, right? So why do we use ROS with OpenCV and PCL? Do you have any idea, guys? Any idea why we are using ROS for doing the perception? I think someone messaged. Tarun said 3D interpretation for better analysis, data transfer between. Yeah, so Tarun, I think 3D interpretation that is not related actually, but the data transfer between nodes is the answer, because one thing you have to understand is that the ROS is mainly a communication framework. The main core part is the communication. Okay, so what ROS can do is just the communication part. Okay, just data transfer. Like if one node is having image, it can be transferred to another node. For example, I can just show you like a PowerPoint slide, and then I can this is very important. So a lot of people will say like work with ROS and interface these things and all. So the thing is that, like, if we have imagine this is a node. Okay, this is a node, this is another node. Okay, this is the third node. Okay, so we have a camera here. Okay, we have a camera. Okay, and first imagine these are like OpenCV code. Okay, it's not ROS node or something, OpenCV code. So first is for color detection from the camera, first is for face detection, first is for motion detection. Okay, so there are 3 programs. Okay, and all the programs has to work from the camera. Okay, so the camera has to interface to this, same camera has to interface to this, and same camera has to interface to this. Okay, so is this configuration possible? Can we do like this, like one device and multiple programs? Is this possible? Anyone? Is this possible? Can we open, like even in our smartphone, right? Only one app can open the camera at a time, right? I think you have observed that before, right? So that is the problem. Actually, if we are using OpenCV or PCL directly, you can only work with one program at a time. Okay, we can work with, I think Tejas is missing something. You can message Tejas maybe. Yeah, yeah. So this configuration will be difficult if we keep on adding more features or more nodes like car detection. Okay, but maybe we can do everything in a single node, and that is not a good way of developing. Okay, it's very difficult to debug, and maybe we have to implement threading or something. Okay, so this will be difficult, like sharing one device. Okay, sharing one device with multiple program will be difficult. Okay, and also it's not isolated. Like here in this program, the face detection, it actually requires the camera. Okay, without that it will not work. Okay, but if you replace this with a ROS driver, for example, just a second. Yeah, I have another program called ROS camera driver. Okay, and that camera driver is working with the camera. Okay, so camera is interface to the ROS camera driver. Okay, and then what happening is that this camera driver is publishing image messages. Okay, so the role of the ROS camera driver node is it is reading from the camera and publishing image messages. Okay, so the ROS topic can publish many kind of data. One of the message type is camera or image. So that means you can send an image between two nodes. Okay, means like you have worked with talker and listener, right? You have worked with talker and listener. So when you work with the talker and listener, you have communicated with text message or string message, right? Instead of string, you can use an image type. Instead of standard message string, you can use sensor message image. Interesting, right? Like you can send any kind of data between two nodes. Okay, so then the situation, like when we use ROS, the advantage is that there is only one camera and there is one driver. Okay, and this one driver can deliver images to multiple programs or multiple ROS nodes. Okay, so then the possibility is actually infinite. You can add any number of node. Okay, so all are subscribing to ROS camera driver, and ROS camera driver keep on publishing it. Is this clear, guys? So why we are using ROS in between? One of the advantages that I'm talking about. Okay, so if you are going like this, there is another advantage. That is offline processing. Offline processing means, imagine we have an expensive camera. Okay, for example, if you check for industrial grade camera, ROS, there is a lot of cameras like point gray camera. Okay, that is one of the 2D cameras. You can find the list from here. Okay, there are many expensive cameras available. Okay, point gray camera, this is one of the industrial grade camera available. So you have to work with this camera data. Okay, you have to work with, but the camera is not available in your site. So currently I'm working with a project in which the similar situation, like the camera and the robot is not with me. It's in the client side. So what I can do is I can start the ROS camera driver. Just a second, and I can do the ROS back. Okay, ROS back. Okay, so what happening is that we are switching on the camera, and maybe in front of camera we are doing some routines like object detection, or we are just showing the object, okay, from the client side, and then we are simply bagging it, okay. And if you have this bag file, what you can do is you can do the ROS bag play, okay. Then that can be subscribed by all these nodes, okay. So do we need the real camera? No. This is very useful because this will helps to work with multiple team members multiple team members, because if the camera is only one, and if 10 people want to work on the same camera, the best idea is to do like this, okay. So these are some of the reason why we are using ROS for the perception, okay, device sharing, and also offline processing, okay. Yeah, and there are a lot of other things as well, but these are some of the important points that I felt, okay. It will be useful for you, these two things, okay. If you have any confusion, you can ask me. So this is the same for point cloud. Like point cloud is again a message type, ROS message type. So if you go to the sensor messages, which is actually a package which is having a lot of standard sensor messages, ROS sensor messages. So you can find IMU type message, then joystick, laser scan, point cloud 2. Point cloud was the first type, but we are using point cloud 2 now, okay. This is the latest one, okay. So the point cloud 2 is the ROS message type for sending point cloud, okay. It can be sent from one node to another, okay. So yes, so that's why we are using what? Perception, ROS perception specifically, okay. This is very important, because if you are simply working on the perception, ROS perception, without knowing the objective, then we will not get that concept, right? But I think now you got a clarity, right? Yes. Yeah. Let me see. ROS perception. Okay. Okay. So in the perception side, two of the important part coming the OpenCV and PCL. Not only that, there are some packages for processing laser scans, okay, laser filters, laser geometry, something like that, okay, and also some packages for doing pre-processing, then calibration. So everything related to the perception of robot comes to the ROS perception stack. Okay, so we already know the navigation stack, right? So navigation stack means the navigation related packages. Okay, stack means a group of packages. Okay, so navigation related packages coming under the navigation stack. Okay, so you can also find in the perception stack image pipeline. So image pipelines are independent packages for doing pre-processing, like if you want to like do some image rotate or image publisher. So these are some kind of tools as well. Okay, so the tutorials are here in the ROS wiki. It's actually mentioned everything. So we can do the calibration, monocular processing, stereo processing, depth processing. All these things can be done using the nodes inside these packages. Okay, so another important stuff is actually calibration. So if you are working in a company or something, and if you are working on cameras, the first thing we have to do is the calibration. Okay, calibration means like calibrating device means like we are actually cross checking with the standard values. Okay, like if you are getting some images from the camera, we are actually cross checking with a standard value. Okay, standard value, and we are calibrating against it. Okay, yeah, Tejas is having a question. As you mentioned that sensors are costly, is it possible to get back files or point cloud data for hands-on practice from somewhere? Yeah, so that is available, Tejas. If you just Google, you will get the back files, mostly like the Velodyne back files. So I have worked with some Velodyne back files. If you check in the maybe you will get the links from Google Drives and all. So, but you have to search search well, but you will get it. Okay. Um, I think currently I'm not aware of the situation, but previously I think 3-4 years back, I think there was a website which is only for sharing the back files, only for sharing the back files. So which was very interesting actually. So but currently like if you check like the some SLAM algorithm, we will get some back files for testing. For example, HDL graph SLAM. So if you check it, you will get the back file for downloading. See, it's actually very, I mean, heavy as well, like 344, and there is some compressed file. But if you want to get a big back file, it will be like more around like 1 or 2 GB size. So yeah, so you will get this kind of back file for testing some algorithm, and I don't know that site is still available, but if I get it I will share. That is having back files for different sensors. Okay, but actually even if you get a back file like this, it may not be good for our application. Okay, so what I meant was, if you are working in a specific application, instead of buying a piece on your office, you can actually bag it and send that file from the client side. Okay, so no need to buy two different units. Okay, but if the development is very rigorous, I think it will be better to buy 2 units, but most of the case we can do it without buying it, just using back files. Okay, hope that is clear to you, Tejas. Okay, so yeah, so that is a perception perception stack. Like there is a calibration nodes available. So if you have the stereo cam, or if you have the monocular means single cam, you can do the calibration using chessboard. So you don't need to write any code for doing the calibration, just run this command, that's it, and just change the calibration pattern size and all, you can able to do the calibration. Okay, so these are the advantages of using ROS. Like there are existing nodes available for doing calibration, pre-processing and all, so you don't need to like worry about developing everything. Okay, and there is nodes for visualization, there is nodes for depth image processing. So these all are like we can reuse all these nodes. Okay, so I think the use of this node is that it is actually converting like depth image into like depth image in millimeter to float depth image in meter. Okay, sometime this conversion may be useful. Like if we want it, then we can do that. And also, in order to create point cloud from the depth image, you can use the depth image point cloud XYZ nodelet. Okay, so these kind of things it's already available, so just give the topics and it will do the job for us. There is another question from Tejas. What is the difference between monocular and stereo? Can you give examples of different types of camera with application? Yeah, so stereo, I think uh, st- uh, it's very clear. I think stereo vision, humans have the stereo vision, right? Stereo vision means two cams, okay, two cams, and using two cams we will get the 3D information, like we are perceiving the world in 3D, right? The reason is the coordination between two eyes, right? So similarly in robot also, in some application we may need two cameras, okay, but in some application we can do with one camera. So monocular cam means only one cam, stereo cam means two cams, okay. And the just a second, using stereo cam, there is a node actually, let me check. Yeah, so left image, right image. Yeah, so like if you have the two images from two cameras, you will get the disparity image. Disparity image means the depth image basically. Like the objective of stereo cams in robot is basically to get the 3D vision. Like human being, we have to get the 3D data from the of the environment. So instead of using a depth sensor, like I can just mention. So you know the depth sensor camera, right? Yeah, these are some of the depth sensors available in the market. Okay, so one of the uh, one of the thing is that, like, if you are using depth sensor, actually it's somewhat expensive. Okay, somewhat expensive, and it is using a different technique to compute the depth or compute the 3D information of the environment. Okay, in real sense there is an option to do stereo cam as well. Okay, but in before real sense, what happening is that the depth sensor like Kinect, okay, it will be only work in indoor. Okay, the technology, they have the IR projection technology. So the IR will be projected to the environment and then it will be reflecting back and it will be collected, and the time of flight, the time of returning to the receiver will be calculated, and the depth of each points will be calculated. uh, and in real sense, the technology is available, the same technology is available, and they have but the stereo cam as well. So the advantage is that it can work in indoor as well outdoor, because camera using a stereo cam vision, you can use in indoor and outdoor, but there are a lot of limitation that I have to say, there are a lot of limitation, but you can use it for indoor and outdoor. Okay, so if you have the stereo cam or monocular cam, there are existing nodes available to process this data. Okay, so here you can find nodes for processing the stereo cam and to compute disparity. Okay, and there are also nodes available for calibration of stereo and mono. Okay, so yeah, so if you just check, I mean, you can use two monocular camera for the stereo setup. Like this kind of expensive camera can be separated in a specific distance. Okay, and that data can be used for processing the 3D information. Okay, yeah, so if you just search for the stereo cam ROS, maybe some ROS supported sensor may be available. Yeah, the famous sensor is SetCam. I forgot that actually. the set cam. Okay, I'm not sure you heard about, but it's very popular. So set cam is actually a set of it's actually a stereo cam. Okay, and they have their own SDK, and now they are also coming up with a computer which is very similar to Jetson. They are using NVIDIA chipset for doing the processing. Okay, so these sensor, no, this is a stereo cam. Okay, and they're creating the point cloud out of it. Okay, so I think the set cam is one of the best example for the stereo cam. Okay, so yeah, is that clear, Tejas? I think set cam is one of the best. Yeah, it's very expensive, you know, like around $100. Not hundred, it's $1,000. Okay, so it's like 1 TB. Oh, okay, $1,500. Oh, too expensive. Okay, yeah. So yeah, that's it. And then yeah, so coming back to ROS OpenCV. Okay, so these are the set of packages available for ROS perception. So just go down and you can find two important packages. So I'm just closing everything. Okay, yeah, so Vision OpenCV and Perception PCL. So these are the two important packages that we are going to discuss from now. Okay, so maybe I can start with the Vision OpenCV. So what is Vision OpenCV? Anyone have worked with Vision OpenCV before, or like if you have any idea, you can say now. Any idea about the Vision OpenCV package, guys? Vision OpenCV. I think I have mentioned this before. If you remember, maybe you can just mention what is Vision OpenCV. What is the objective of the Vision OpenCV? Any idea? Maybe you can comment as well if you have an idea about what is Vision OpenCV. Okay, maybe I can explain. So the Vision OpenCV is it's very useful package, I will say. Okay, so what is its application? The application is very simple. The Vision OpenCV can help you to bridge between OpenCV image data type and ROS message. Okay, so you may have some confusion. What is the image data type and ROS message? So you already seen that ROS is having a message type called sensor message image. Okay, so this is a ROS message type. Okay, ROS message, what is a ROS message? It's actually kind of data structure, okay, for holding a kind of message. Okay, and this message will be sending or publishing or subscribing by the nodes. Okay, so this type, so in order to send a ROS image, okay, maybe we can come back to this this point again. Okay, so in order to send, okay, in order to send the camera data from the real cam, in order to publish the image messages, okay, so what can we do actually? So we have to send sensor messages slash image type. Okay, so basically the ROS camera driver should publish a topic with this message type. Okay, and all the nodes will be subscribing to this type, right? That is what we have to do. Okay, then only this ROS communication will work, right? So when we connect the camera to the ROS camera driver, or when we connect the camera, the ROS camera driver will be reading the images, right? Reading the images. So the camera driver is keeping a data type for keeping the image data. Okay, so the camera driver may be either use OpenCV. Using OpenCV function, we can simply open a camera and read the image from it. Okay, so basically the ROS camera driver is having image in the format of OpenCV data type. Okay, but that data type has to convert into what? Sensor message image. Then only it can publish it, right? And then only this camera driver can publish. So the Vision OpenCV packages, okay, it's a list of packages. That package will help to convert the OpenCV data type. Okay, OpenCV data type called CVMAT. Okay, this is a class actually, okay, to hold an image. So in order to create an image message, you can like give like this. Okay, so image is the image variable. Okay, you can actually hold a image data in the image variable. Okay, so the image variable has to convert into what? Sensor message image. Okay, so basically the concept is the data type that is using in the OpenCV has to convert into sensor images, okay, sensor message images, and vice versa. Okay, like after subscribing the image message, how to process this image? How to process this image? This has to convert back into CVMAT. Then only we can process using OpenCV, right? So that conversion, like CVMAT to sensor message image and sensor message image to CVMAT, is doing by what? Is doing by Vision OpenCV. Okay, or called CV bridge. Okay, so there is a question from Rohan. So what is the difference between RGBD camera and stereo depth camera? Stereo camera, okay. So the RGBD camera, that is what the Kinect or RealSense is. It is having an RGB camera with depth. It's basically commonly we called RGBD means the depth camera. Okay, stereo depth camera means it is having two RGB cameras. Okay, so stereo means two. Okay, so two webcam or two monocular cam, combination of two. RGBD means like Intel RealSense is an RGBD camera. It's an RGB. It is having an RGB cam as well as a depth processing happening as well. Okay, so I think that is the main difference. Okay, yes. So so this thing, the Vision OpenCV packages are helping us to convert what? Helping us to convert the ROS message into OpenCV data type, then OpenCV data type to ROS message. Okay, so like let me just show you that Vision OpenCV. Yes. Okay, so I'm just sending the link, so you can able to see the Vision OpenCV is having CV bridge and image geometry. We have to look on to the CV bridge, which is bridge between ROS message and OpenCV. So this is what happening. in the CV bridge. Okay, so there is a small correction. Maybe I can correct it here. Just a sec. So there are two blocks. Okay, and here it is CV mat. Here it is sensor messages / image. Here it is OpenCV. Here it is ROS. Okay, and the CV bridge is in between. Okay, so the difference was maybe I can just show you. There is a small difference. The difference is that this is an old image. Okay, so it's saying OpenCV IPL image, right? So IPL image is the oldest data type that OpenCV was used. Okay, this is a C data type. Okay, data structure, you can call it anything like. So IPL image was the data type that used to hold the image when the OpenCV released. But after that, now it is CV mat. Okay, CV is the namespace, mat is the class. Okay, for holding the image data. So CV bridge is actually a set of functions to convert OpenCV images into ROS and ROS image into OpenCV data type. So then only we can do the publishing of the image from the camera driver and processing of the image from these nodes. Okay, so do you have any question, guys, regarding the CV bridge? Any questions? Any questions? Okay, so I'm just sharing some tutorials as well. Maybe I can show you the working of the C++ tutorial. Okay, then after that, yeah, in this image it is got corrected. So I'm just showing the example that is mentioned. After that we can conclude. Okay, then I can explain the code of this maybe tomorrow. Okay. Okay, so let me show you the demo of CV bridge. Okay, just a second. Let me add my webcam to VMware. Okay, it seems added. So I just want to take the webcam application, which is cheese, and now you can able to see me, I guess. Yes. Okay, and now let me start the CV bridge application. Okay, demo.launch. Okay, it started. Topic list. Okay, so currently what I did was I actually started a launch file. Okay, so which is having a node which is which is actually doing edge processing. Okay, edge processing, but it is actually waiting for what? Images. Okay, because I didn't start the driver yet. Okay, so now I need to start the driver. So there is a common package available called USB cam, which is supporting almost all the USB based webcam. So if I'm starting that, this is a driver program which is publishing the data, image data. So you can see this is the raw image and this is the edge detection. Okay, and I can show you the RQT graph for more understanding. It's very simple. Just a sec. Yeah. So what is happening is that there is a driver node called USB cam. Okay. What it does is that it is publishing the images. Okay. So it is reading from the camera and publishing the images in a topic called USB cam image raw. Okay. Which is subscribing by CV bridge node and which is also subscribing by image view node. Okay. So the image view node basically doing the visualization of the image, and this is the CV bridge node which is actually subscribing the image and doing processing using OpenCV. Okay, so we can simply check the topics. So the raw image that is coming from the driver is this. So you can just check ROS topic info image raw. So you can find it is sensor message image. Okay, yeah, Tejas is having a question. So USB cam is the ROS driver here, right? Yes. Okay, so if you just search for USB cam, okay, USB cam ROS, you will get this package. Okay, it's already available in the Synaptic Package Manager. So very easy to install. Sudo apt install ROS Noitic USB cam. Okay, so this will be installing the USB cam driver. I think currently it is upgrading. Okay, the upgrading. Yeah. So it's already installed, but it is upgrading. Okay. So here the USB cam is a driver. You can find the description. It's a ROS driver for V4L USB cameras. Okay, but if you are using some EtherCAT based cameras, you can check whether any existing driver available. Otherwise you have to create your own. Okay, it is somewhat difficult, but you can able to do. Okay, so the driver is publishing the images, other node will be subscribing to that image and then converting into OpenCV data type, and then again converting into ROS messages. Like that is what happening actually. Okay, yeah, so maybe I can do the demo again just for the clarification. Starting the driver. Okay, so driver just started, and also there is a visualization and starting a node which is doing the computer vision application. The application is edge detection. So here what happening is that it's doing the edge detection. Okay, and it is visualizing. Okay, and that image, the processed image, is actually publishing as a topic as well. Okay, I can show you that. Just take the RQT, and in RQT there is a plugin for visualizing image called image view. Okay, so you can see you are visualizing the compressed image. If you change to edge detector raw image, you can see the raw image is getting here. Okay, okay, so I'm just adding the node graph, so you can see how it is working. No, it's already okay. Yeah, the USB cam is reading the images from the camera, then it is publishing a topic called image raw, which is subscribing by image view and the CV bridge node. Okay, the CV bridge node is again processing. I mean, it is subscribing by CV bridge, and after subscribing, it is converting into OpenCV data type and doing the edge detection, and then that edge detection image is converted again to what? ROS image. Okay, so that is this. Okay, so input is image raw, output is edge detector raw image. Okay, okay, I think we can conclude for today. Now it's a time for questions. You can ask question, guys. Tomorrow I will be explaining the code to you. Okay, and we can start with PCL as well. So let me know if you have any question in the perception as a whole, and also specifically the CV bridge. You can either comment or you can unmute your mic and ask. Any questions? Is it clear, guys? It's actually very simple in the sense like it's basically a publishing subscribing, but there is a conversion happening. That's it. Yeah, I think Rohan is having a question. Yeah. Rohan, maybe you can you ask directly? That will be faster. I can also show you the okay. So yeah, so tomorrow the objective is explaining this code to you. Okay, how we can do the conversion, like subscribing to image, then converting into OpenCV data type, those stuff, and also the perception PCL. Okay, how to do the 3D perception using the perception PCL. Okay, which is again a bridge between PCL library and ROS. Okay. Okay then, guys, if you have questions, you can post it in the discussion channel. Okay. Yeah, so tomorrow I think, yeah, we can do the same time. Okay. Okay then, bye everyone. Thanks for attending. Bye. Okay, bye.